All right, section 5.1, mid-segments of triangles. So our mid-segment here. So if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. All right, so let's look at how this works. We get a triangle out here. I have a triangle. And I get the midpoint of two of the sides. I find the midpoint of this side and the midpoint of this side, and I connect them. This right here is a mid-segment. Okay. That segment is going to be parallel to the side it does not touch. So to the side it does not touch. So parallel to that side. And it's going to be exactly half as long. So this right here is going to, there'll be two of these in there. They'll be exactly half. So if I grab it, should be parallel, which it is. And if I clone that, there's two of them that fit in there. Okay? So it's parallel and exactly half as long. All right, so graph the vertices of triangle ABC in the coordinate plane below. So we have 4, 6. There's point A. Point B is at 6, 0. And C is at 0, 0. All right. We have our triangle. Now we want to find the mid-segment. And we want to go ahead and show that the mid-segment is going to be half the length of the side it doesn't touch. And then I also want to look at it and show that it's parallel by comparing the slopes. We know that two lines are parallel if they have the same slope. All right, so let's find the midpoints of AC and BC. So remember our midpoint formula. We can add the x's together, divide by 2, add the y's together, and divide by 2. So A is 4, 6. C is 0, 0. Okay, so 4 plus 0 divided by 2. 6 plus 0 divided by 2. The midpoint is going to be 2. The midpoint is 2, 3. So I go over 1, 1, and up 1, 2. There's the midpoint of AC. So add the x together, divide by 2. Add the y's together, divide by 2. We're going to label this point P. Next, I want to find the midpoint of BC, this bottom one. This is a little bit easier, right? I can just find the length. So 1, 2, 3, 4, 5, 6. Half of 6 is 3, so I go over 1, 2, 3. There's the midpoint of BC. That midpoint is going to be 3, 0. That midpoint 3, 0. And we're going to label that point E. And point D was 2, 3. And this is a mid-segment. So first, let's check the first part of it. Let's check the slopes. Let's ask ourselves this question. Is DE parallel to AB? So is DE parallel to AB? So first, let's just count rise over run. We know DE M of DE equals, you go down, 1, 2, 3 over 1, negative 3 over 1, which is negative 3. And let's see the slope of AB. Count our slope, down 1, 2, 3, 4, 5, 6 over 2. So negative 6 over 2 also equals negative 3. Do DE and AB have the same slope? Yes. Right? So are they parallel? Yes. Right? So the first part of our mid-segment theorem that we've shown is that if I connect the midpoint, two sides of a triangle, it is parallel to the third side. The next thing is that it's half as long. It's half as long. So let's find the length of DE and the length of AB using our distance formula. Let's see if they are in fact half. So the length of AB. Remember how we do our distance formula. We're going to put these shells together. Where we just have to remember we're going to put our x's together and then put our y's together. So AB, x's together, we have 6, so that's our y's. Our x's, we have 6 minus 4. And our y's together, 6 minus 0. So I end up with 2 squared plus 6 squared. So I end up with the square root of 40. And we can write the square root of 40 as the square root of 4 times the square root of 10, right? And we know the square root of 4 is 2. So the length of AB is 2 root 10. Right? What I'm hoping when I calculate DE, the length of DE is going to be half the length of AB. So half of 2 is just 1. So hopefully the length of DE is just the square root of 10. Right. Let's again set up our distance formula for DE. Then put our x's together and y's together. So we have 2 and 3, and 3 and 0. So I end up with negative 1 squared plus 3 squared, all square rooted. So 1 plus 9 is the square root of 10. So the distance of DE is root 10, which is in fact exactly half the length of 2 root 10. It's half the length of AB. So we've shown two things. Mid-segments, connecting midpoints of sides. When we connect the midpoints of two sides of a triangle, the mid-segment will be parallel to the third side and exactly half as long. Actually, all right. So first, let's look at the parallel ones. What are 3 pairs of parallel segments in triangle DEF? So that big triangle, triangle DEF. So I want to know what is parallel to DE. Parallel to what? EF. Parallel to what? And then FD parallel to what? All right, so let me do the first one. I'll give you a chance to take a look at the next. All right, so we have EE right here. The mid segment is the one that doesn't touch it inside here. So it connects the midpoint of these sides. So that would be parallel to S. So go ahead and see if you can find the next two. I'll take attendance real quick. All right, so EF, we'll do this in green color. This guy is going to be parallel to R. And then FD, this segment right here, is parallel to RX. So the next one, in triangle QRX, TU and B are midpoints. What are the lengths of TU, UB, and QR? I want to find the length of TU, UB, and QR. All right, so first, TU, this segment right here, we know the length of TU is going to be half the length of the side it does not touch. So RS is 40. Half of 40 is 20. Let's see if you can find out UB and QR. See if you can find out those next. UB, this segment right here. The side it does not touch is SQ, which is 50, so half of 50. 5. Next one. QR is this entire segment up top. And we have the mid segment. It's 30, so twice 30, 60. Easy enough. All right.
Wait, how do you do the last one?
We double this. So this is 30, so that is 30, and that is 30, so it's 60. Notice what we're doing. We're creating 3 or 4 congruent triangles within each of these. They're congruent by side, side, side. All right. A geologist wants to determine, here's a practical application to this, the distance AB across a sinkhole. Choosing a point E outside the sinkhole, she finds the distances AE and BE. So AE, right, and BE. And then measures the distance across the sinkhole. So what she did is measured this distance here, and here to here. And he wants to know how far it is across here. By setting up this triangle so she can measure this length here, she can measure something indirectly that she couldn't necessarily measure across. So what is going to be the length of AB? So we know that AB is going to equal 2 times DC. AB equals 2 times 46. AB equals 92. So the distance across the sinkhole is 92.